How's it going, everyone? Welcome, Oliver Gonzalez again on the Enterprise UI Development. So today we're gonna now take a look at how can we now not only protect our branch, especially when you want to guarantee the maintainability of your code, which is the ability that not only you can add or change code, but also that you can migrate or do a refactor without the fear of breaking something, which is something that a lot of company will appreciate, and you as well, because you are going to face new challenge. So even though, right, because of that, we're gonna make a quick recap of how do we get here, all right? Because this course is focused on the maintainability of large code bases with a wide range of collaborators in large teams. And we started by describing is what are the things that makes a code maintainable: the ability to add, change, migrate, and do a refactor without the fear of breaking something. And this course focuses on how can we now build the infrastructure needed to guarantee that, right? First things first is to understand what are the components of a well-architectured UI, at least at 2024, is that you must have this particular pyramid, okay, of needs when you start first by setting is the testing system, and then the build system, and also the static analysis, which is something that we're also gonna do. And once at least you have that foundation, that infrastructure, okay, now it is time to look at what are the process that we can do as a way to make that maintainable code much easier to do. So process like code review is one of them. Branch protections is another one. It's also part of the code review. So you have code review, blueprints, document designs, right? How is your process? So what would be the process of adding, removing, or in this case not removing, but adding, modifying, or do a migrations, bump up a npm versions, for example. And then once you already have that particular process, then you're going to now face is this pattern, or this top of the pattern, which is, all right, now that we know this, okay, anytime that this particular things happens over and over and over, anytime we need to build a software, anytime we need to develop a UI for companies, for big companies, so now we know what are the patterns that we can replicate, right? And that is, what we need is the architecture. What is the architecture? The folder structure that we're going to provide as a way to now set up the foundations of maintain this enterprise UI projects, as well as what are the common things that we do, especially as we are now able to add new features, which is what are the patterns there. So for example, it's like, hey, how we manage the state as one. It's like, hey, how we for example, it's like how we manage states. That's one. Anyway, how we manage states, how we now organize our projects. What is the folder project structure for that? The architecture. What are the abstraction that we're gonna use for that? Because this is recurring problem. Is that, hey, we need to make this particular code be independent to others, right? What are the abstractions? So all of this is something interesting, right? And we started to see the fundamentals, this base of the pyramid of the base of the pyramid of needs when it comes to make a sustainable code base, aka maintainable. So for that, right, we also dive deep into some of the concepts, especially of what it means, the word maintainability, and as well as the infrastructure, where the infrastructure come from, as well as the economy. All right, because we are all doing this is not only to give us the ability to maintain the code, but also to do that with for its economy, for the business, for the judicious use of resource. Is that anytime we need to actually add some code, change or migrate or update the dependencies, we can do that in an effective and fast way possible. So the tools that we are looking, or the tools that we're going to use here is React, TypeScript, V testing library, and Playwright. Okay. So I'm not going to dive deep too much. Just briefly describe these things that we need to do as the foundation, which is the unit testing, the testing systems. Here we look is at the spectrum of the testing. You have the unit, you have the end-to-end, and in the middle you have the components and integration tests. We also look at how can we make ourselves familiar with the terminology of unit testing, which is one of the things that is much faster to write by understanding the tests, the test suite, the assertions, and well, actually how can we write is a test using now Jest framework, particularly in Vite, which is this build tool that allow us, which is reading in it used the ES build, which is reading in Go, which provides HMR and faster build. Is also compatible with Jest, so you can now easily migrate your test to Vite, which is a great thing and a huge relief, especially if you have a lot of tests you are doing that migration. Okay, that's something interesting that we can do by actually testing that. Yeah, completely. Totally. And then we look at the greatest hits on testing, unit testing, using the tool from Vite or Jest. Right. One of the benefits of VTest is that it provides you a gray error report. It has a flexible configurations. You can handle in browser-like environments as well. Something that we're gonna see that, which is part of the end-to-end. Okay. And how can we now write our tests, which is something important. And that is specify the setup, the test logic, and ultimately one single assertions. And when you're doing that, some of the things that you want to use or the greatest hits tools is that, well, you have now the to be equal, the to be what is checking is the referential equality, which is, hey, if this value, is this two object has the same reference in memory. The other is the value equality. For example, using the to equal, hey, is this object, it is list of property and values are the same, good. And also other properties or other methods like to be close to, which is useful for floating points. To be instance of, it's going to look at the internal proto reference of this object, and if it has at some level of the prototype change a function constructor, good. Then I also look at the contain, hey, these elements are on this collection of elements. To throw, useful for checking if a function do what it's supposed to do. To match, for string, to match objects for objects, expect any, which is useful for checking the types. And another useful thing is like expect array containing or object containing, which is something that when you want to check a subset of elements in an array or properties in an object, you can do that using that. So this is one of the examples that we did. So far so good, nothing too weird and complicated. The only thing is that anytime you want to write your tests, create a function for that, because functions are easily testable. And what are the advanced topics that we need to do, especially when we want to actually run or async the tests, or these advanced techniques, right? So whether it's using async and await, or expect result or expect reject, useful for detecting is if a promise fail, right? And some tips, especially when you want to now write or when you want to solve, is a bug report. Okay, so you have now the problematic ticket. You take the ticket, you take the problematic code, you write a failing test to make it pass. And that's something that you can do, that this is part of this process that you can automate there. And the other is when you want to actually check for elements on the screen that appears on the screen. Well, you can use the timer for that, as well as date now. And there's some also techniques that you can use when you want to set that fix. So far so good. All right. We also look at how can we now test React reducers. Okay, functionality functions, especially useful for Redux. This battle test state management. When you want to guarantee that you're gonna get this state update as expected. Similar for the actions, right? So Redux, at least Redux RTK, actually speed up the development of this kind of things, which is a great thing. Okay. It speed up the process of creating actions, creating action types, as well as the how do you put it? The creation types, as well as the state and the reducer. It actually generate all of that for you, and this is one of the main use cases that you can use unit testing for the UI development. All right, you can also do that for the backend. All right, as a way to check if a particular controller actually do what it's supposed to do. That's quite interesting, right? Most of the time, those tests that we look is basically on the UI. Most of the time. So, with that, knowing the testing system, then we move on to the build system, which is part of the practice that we are going to look. Or what we did is something that we're going to take a hands-on approach by writing our tests and looking at some of these advanced techniques. We're going to now go into our first foray to set up our build process for the affirmation test to check that everything works as expected. And that is first to understand now what is this GitHub Actions. And this CI/CD process. This is the way of how you can now automate certain part of the code, which is something that I really love about that, automizing stuff here, which is awesome. But it's that, so we're gonna automate is the build, the testing, so testing and building. All right, building testing and building. So generating code, covering report is another thing that you can do with this automation here. So anytime you add something, you want to generate a coverage report, and also saving playwrights video. But the thing here of this, especially for the UI development, okay, is that we are now have a particular process in which we can now is automate certain part of the code of the software development. So you have now the plan and the code, and then you using a peer, which is actually using Git behind the scene, which is this version control system, distribute version control system. Which what it does is to only keep track of all of this diff that you are applying to a code base and store that, so you can actually see the history. What's next? So once you make a PR, all right, when you want to try to integrate your code by using as a PR, you want to make sure that those code won't break your app or fail test, that you want to make that those changes won't break your app or fail some tests. Okay, so that's why you pass is the build and the test to generate a new artifact, and that artifact then you can pass it to a staging environment, all right, where you can now is test everything close to production. All right, this is part of the continuous delivery, and then finally by doing some code review process, depend on the application. For example, if it's software, you can actually integrate that to continuous delivery. All right, but if, for example, industries like healthcare or defense or hardware, you want it to be very specific about it. You want to have now a manual review. So, and then once you do that, you want to see that works as expected. You operate on this new change, and then you monitor that. So that's the entire process here of how you're going to integrate code and delivery, right? Delivery and deployment. So this particular process, okay, which is something that I will argue that it will be automated. That I argue that this is a process that will be automated as much as possible. So there will be a lot of layer of abstractions to avoid all of these repetitive and monotonous tasks here. But those parts that require human are those things that it'll say, well, we need to find a way to figure it. We need to find a way is to create trust or consent in those areas, right? Again, so this is where now the different aspect of this engineering interlaps, right? So you have now the UI, and you have the backend, and you have the DevOps, and at the end of the day, all of them want the same thing, which is automate repetitive tasks that they have to do. So that's why we're looking at GitHub Actions, and GitHub Actions, so GitHub Actions allow you to automate some of this process in your workflow, okay? So one of the main use case for this is that if you have a SaaS and an open source, and if you want to bump up the NPM versions, it will automatically bump up the NPM versions of the cloud. So instead of you having to go to the branch, create a new PR, get the PR approved, and then merge that and then publish those changes on that on the open source repo, on that particular repo. Once that is done, you don't only have to do that in that repo, but also on the PM register. But now this is something that is automated. Another useful case is, well, for building and testing your applications on PR, deploying your app every time a release is created. Okay, so once it has been approved, all of those changes, is that okay, now let me automate this deployment process when a release is created. Okay, that's something that is very, very critical as well. And the other is adding a layer or adding a label when a new issue is created. So that's something interesting. That's very, very interesting. So this is at least the four main case of how you can now provide a maintainable code along large code bases. Okay, so that's great, and we're starting to do that by using the GitHub Actions workflow and looking at the anatomy. So anatomy is that, well, this workflows is a configurable YAML file that allows you to run one or more jobs on GitHub repos. Okay, and they are defining on the .github/workflows in plural. This workflow can be reused, which is a great thing. And you also have now events where it's a set of activities that is defined by GitHub on your repo, or schedule that you define, or requests or posting to REST API, right? So this particular thing, posting to a REST APIs, to me was not that clear. The other was crystal clear. GitHub Actions Anatomy. So GitHub Actions Anatomy. Okay. Exactly. Particularly this, by posting to a REST API or manually. For example, an activity can originate from GitHub when someone creates a pull request, open an issue, or push a commit to a repo. You can also trigger a workflow. You can a specific activity that triggers a workflow, and you can also trigger a workflow, all right, or this automated process to run one or multiple jobs. Okay, in this workflow, so a real example of a workflow. Something that we use daily in a workflow, an automated process for that. We can a workflow can be is prepare a meal. Okay, so that can be seen as a workflow, that can be seen as one task that you need to do. All right, and this task can be described in several steps. Is that, hey, you need, example, you want to prepare you want to make a Mediterranean meal, right? And that is, well, you want bananas. You want bananas, pancake, eggs, strawberry, and then you need actually is define all of this set of steps to there. So this is a real life example of how you can do that. Another workflow is like, hey, I'm going to do this anytime to hit the gym. Okay, this is the workflow for the gym. okay, for doing exercise today. And this is the serious help step that you're gonna do that. One of the powerful thing of this workflow, of this automation of things, which also have illustrative, is that our mind is designed, correct me if I wrong, some of these neuroscientists and psychologists, our mind is designed to be lazy, because lazy is efficiency. In other words, we don't want to constantly thinking about what we are doing. Our brain can handle that huge cognitive load. So that's why we automate a lot of this process. And even though, especially when we talk to people on the streets, is that we have some social mechanism in place to actually do what we have to do. If we find someone actually on the street and they salute and they say hi or they ask for something, we have this defense mechanism, right? It's like, yeah, okay, cool, you have this workflow of how you can do it. Because at the end of the day, again, the mind just one is to how do you put it? The mind just wants to save energy. So this is a good example of this workflow, all right? For prepare a meal or hitting the gym. You can also go more complicated, for example, when you are when there are several steps that needs to happen in parallel. When you start the engine of your car or the motorcycle, all right? Good. But this is what is workflow. The thing is that those workflows can be triggered by events that can happen at GitHub level, okay, or by scheduling that. Okay, you can define some jobs on a schedule, or by posting to a REST API or manually. By posting, this is something that is not quite familiar. It's like create a repository dispatch event by posting a REST API, by posting to a REST API. You can use this endpoint to trigger a webhook event called repository dispatch. When you want activity to happen outside of GitHub, to trigger a GitHub Actions workflow or GitHub app webhook. Oh, you must configure your GitHub Action workflow or GitHub app to run when the repository dispatch event occurs. Exactly, you must configure the GitHub Action workflow or GitHub app to run when the repository dispatch event occurs. For an example, repository dispatch webhook webhook payload, see repository dispatch event. So what? Okay, you want to dispatch now, and you want to post. Posting to a REST API. Okay, giving an activity on this repo. I want to post to I want to post to. Okay, giving at this repo, I want to post to an API. I want to send. I want to send a post to an API. Okay. Create repository dispatch event. Repository dispatch event. Availability for repository dispatch, GitHub Action. Okay, you can dispatch repos events here. Webhook payload object for repository dispatch. Action branch client payload enterprise installation organization repo sender. Repository import. This event occurs when a repository is imported to GitHub. Okay. Webhooks. Learn about when each webhooks event occur and what the payload contains. And a webhook event and payload is here. You can create a webhook that subscribes to events listing on this page. Okay, to limit the number of HTTP requests to your server, you should only subscribe to specific events that you plan on handling this. This is part of the webhooks. Okay, posting. Okay, makes sense here. Makes sense. So posting to a REST API. So this repo can dispatch a particular event to a or send a post to a REST API as a way to detect or do something outside of the GitHub actions. Okay, webhooks. Interesting. So this is one of the activities or the events that we can respond to that. That'll be interesting to actually create now is a GitHub action here. And the using is OctoKit. Okay. And the using is OctoKit here. Code sample for create repository dispatch event here. And the status 204. No content. Resource not found and validation fail of the endpoint has been spammed. Okay. Alright, so but this is the most common things that this event, this set of activities that when triggered, that when it's detected, it triggers a workflow. Okay, so this workflow, which is made of a jobs, one or more jobs, which jobs are series of steps that run on the same runner, and a runner is this newly fresh virtual machine provided by GitHub that allows you to run one job where every runner can run a single job at a time. And these virtual machines are it can be OS, Mac, or Linux, okay, which is great. And this runner, okay, and this runner, which is part of the jobs, okay, where jobs are executed on the same runner. You have now a series of steps that can either you have the series of steps that it can be either a bash script or an action, which an action is just a custom app that do monotonous that automates frequently tedious repetitive tasks, which is great. So this series of steps executed is in order and it depends one on another, and because of these steps are running on the same or are executing on the same runner, they can share data on this single job. Okay, so jobs are executed by default in parallel. Okay, so GitHub Actions now provide you is all of these virtual machines per jobs, so you can run all of these series of steps. And in this series of steps, what the use case is like, hey, we want to pull the repo we want to pull the repo from GitHub. We want to now set up the build tool, the build chain tool. Or we want to set up the correct tool change for to build your environment for your application. That is, for example, it can be Node. Okay, set up an authentication to your cloud provider. All of these things started to make sense, especially if you're able to describe what's going on. So yeah, this is the key points of this. This is isolation and parallelization. It's important to understand that the anatomy of this GitHub workflow. You can provide it, give you now granularity and also reusability, and it's flexible. Okay, so this is how we can now build our first or first this adding a test. No, it's not here. Fix typo, add a build step like this. I don't know if you, let me see if we can actually view files. And then you got it. It's pretty simple, pretty straightforward. You can get very, very weird and start overcomplicating of this kind of thing. But the thing here is that it's like, yeah, it's pretty much this. It's pretty much this. We also look at these GitHub Actions on Git as a way to see what went wrong. Really? Well, this is indicating is how many seconds it took. Okay. You can filter for that, or you can is filter by events or the status, which is quite interesting, by branch. Okay. And by actors. Hello. Interesting. Run the unit test. Okay, which is now explicitly is telling you which workflow you define here. Run unit tests. It actually filter workflow, as you can see here. Filter workflow. What runs is showing this catch. Right now we don't have any catch or attestation. And the runners. Remember, the runners are this virtual machine that are providing you per jobs, where it can only run one job at a time per runner. Okay, large GitHub hosted runners. This is on Provision, standard GitHub host runner, ready to use and manage for that. We got only one available, standard GitHub hosted runners. About GitHub hosted runners and monitoring your current job, which is another part of the process of CI/CD, and customizing GitHub hosted runners here. There you go. Okay. GitHub, about GitHub hosted runner, overview of GitHub hosted runner, using a GitHub hosted runner. Okay, it's telling you which can you, right? As you can see, so this workflow can have multiple jobs, and each jobs are run on the same. Jobs are run on the same. Jobs are run on the same runner, and a runner can have and a runner can run just single job at a time. Okay. So yes, a step, exactly. It's a set of steps at executing on the same runner. And runners, okay. And runners can run a single job at a time. And as you can see, those runners give you now is a virtual machine. When the job begins, Git automatically provisions a new virtual machine for that job. So it's creating is this virtual machine. Say this computer here. It can be Ubuntu, Mac, Windows, right? And all step in the job executed on the VM, right? Allowing the step that a job is doing that. They're using VM. You can run workflows directly on the VM or in a Docker container. When the job has finished, the VM is automatically decommissioned. So the question here is that by default, we're assuming that by default it provides you a virtual machine for that job. You can specify to run that on a Docker, okay, which is here npm Ubuntu run PSK script analyzer on window, and that kind of thing. So this is quite interesting, very, very interesting. And also telling you what is the what is the standard GitHub hosted runner for public repository. And the thing here is that behind the scene there's spin up for every task, for every workflow, for every event that trigger a workflow. It is spinning this new computer. It's like sending you a new computer with all of these instructions and running your application, see that everything works, and then disappear over and over and over and over every time every time a event triggers a workflow. That's wild. That's wild. That's very, very wild. That's one of the reasons why a lot of people actually use Linux instead of Mac, because it's much more cheaper for that. And that's quite interesting. Standard GitHub hosted runner for private repos. Okay. Limitations on ARM, macOS runner. Large runners. Interesting. Pre-install software. Viewing workflow run history. That's right. Cloud host used by GitHub host runner. Workflows continuity. If GitHub Action Service are temporarily unavailable. Okay, but the idea of this is to understand now, to have a bigger picture of this workflow anatomy. So good, we already write that. We know at least the basic stuff needed. And anytime we read this particularly file, we know what's going on, and that's something important, especially if you are going to use a particular tool. Here we're looking is that now how you can set up your branch protection, okay, and how this thing becomes now part of the process, part of the once you define the unit testing, the testing infrastructure or the testing system instead of the build system, this kind of activities becomes part of the process of how you can make sure that your code is maintainable. So for example, anatomy of a simple brand protection is to make a PR before merging, especially to main. Let me actually take a look at this. In fact, I already did that. Yep, I already did this with no, but this is read more about that because I already on the settings and branches here, looking at the main, and I did this protection rules. I put this require approvals, and it is funny because require review from code owners. This can be something that is problematic or not. You can also useful, especially when you want to now put your code to an staging environment, from main to a staging environment. This can be something useful, especially to ask for senior developers that, hey, what's going on, what will happen, that kind of thing. Good. Good. Require status check to pass before merging is like, hey, we want to make sure that those changes won't break our app or fail the test, right? We don't want a broken apps or failed tests passing to. Okay, require branch to be up to date before merging. Require conversation resolution before merging. Require signed commits. Require linear history. This is a way to say, hey, prevent merging here. Use a rebase. something that I am not familiar but I need to do. Require deployment to succeed before merging. Local branch is like, hey, is everything safe? Is you put everything in local. Branch is read only. Users cannot push to the branch. Do not allow bypass the above settings. Allow, and this is rules applies to everyone, including administrator. Allow force push and allow deletion. This particular thing here is something that is as an admin of this code base, you have a huge responsibility to do that, and then you can also get also nasty or naughty to do that. So to prevent that, it is important to provide the administrators, or even the admin or any users, with the least amount of rights. Follow the principle of least privilege. Okay, exactly. So because the admin can have because the admin provides rights to the collaborators, because the admin provides rights to code collaborators or code contributors, okay, that's right. So because the admin provides rights code contributors the access to certain areas that are crucial, or that are essential, imperative, that are paramount to security. Admins here provide is the principle. So admin here follows the principle of least privilege, right? Privilege, right? Oh my god, the principle of least privilege, right? The principle of least privilege only provide the necessary rights to this user.
It's open source. If there are lint warnings now, I'll also see that here as well. It'll like annotate the PR with like, yo, this didn't break the build, but like you got a little silly thing here, right? In this case, it's just showing you like, because you think a lot of these stack traces have the file name and have the line numbers and stuff like that. So it is able to kind of like show you, and complete with error code of 2. And so I fixed those, and then I added them to the commit. So go back to actions, and you can see that it passes at this point, right? You get a sense of like what branch it was on, so on and so forth. You can filter. In this case, we're only doing a pull request. You can hear all the different statuses. And I will show you some of the events you can watch for in a little bit as well. The branch and the actor, there is one. It is me. Cool. So here you can see that in this case it went successfully, which means now I know that, hey, this builds before merging the main, and all the tests pass, right? Like, great. Now nobody has to run it manually or anything along those lines. We now know with confidence that theoretically you can't merge bad code into main. The word theoretically is doing a lot of work in this sense because I totally can, right? In fact, there are no rules in this repo. I can do whatever I want. And as an admin, you can always kind of do whatever you want. But like, this is why like most companies have like principal police access, which is like at most decent sized companies, not even anyone on your team has admin access to your own repo, right? And it's to stop you from doing things like this. Because in a lot of cases, there are rules around things you need to do to be compliant to, its name is a SOC 2, is that?
Mm-hmm. SOC 2. Mm-hmm. Mm-hmm. Akamai and Atlassian. Auditing standard board. Okay, auditing standard board for American Institute of Certified Public Accountant. They don't mention it. Mm-hmm. 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 And positive security posture is vital in the era where cyber attack proliferates. Cyber threats such as ransomware and phishing continue challenging companies across all the sizes of all sectors. Also, supply chain attacks have become a serious issue, with survey by World Economic Forum finding that 90% of the respondents were concerned about the cyber resilience of a third party. Frameworks are designed to help guide companies in implementing a robust security posture. One such framework is SOC, System and Organization Controls 2, which work to establish risk and improve operating effectiveness. Mhm. 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 And this is now Mhm. 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 Quality assurance or policies. Security frameworks. Mhm. This is more like legal. Legal. SOC 2. Security framework, man. Security frameworks. Mhm. So you have now SOC 2. The other is data privacy, and that is CCPA, Consumer California Consumer Protection Act, California Consumer Privacy Right Act, and the European what's next? The GDPR. Mm-hmm. Interesting. Very, 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 very. This is part of the legal. Because we don't trust. I didn't set the rule, bro. I definitely didn't set the rules. Mm-hmm. Security frameworks, data privacy. Mhm. Zero trust security. It's a network security strategy. Mm-hmm. And these are articles. those are oh my god, those are those are articles. Those are articles fairly recent. Continuous monitoring and validation, least privilege, device access control, microsegmentation, preventing lateral movement, multi-factor authentication. And this is part of the policies. Okay. This is part of the policies. By analyst Forrest at the Forrest Research in 2010, when the model of the concept was first present. A few years later, Google announced that they have implemented zero trust security in their network, which led to a growing interest in adoption within the tech community. 2019, Gartner, a global research advisory firms, lists zero trust security access as a core component of security access service edge case. Security access service edge. Replacing or augmenting VPN, securely support remote workers, access control for cloud and multi-cloud, onboarding third parties, and contract. What do you expect, man? If this company have this particular policy, and they, security teams talk about is zero trust, and to actually protect their assets, and their marketing team that the HR say, we are a family in this company, so they're playing games, man. And people will gonna eventually people are not stupid, man. People are not stupid, and they will find out a way to actually get what they need, bro. I'm sorry. What the main zero trust best practice? Monitoring traffic and network and connected device visibility. Keep device updated. Apply the principle of least privilege for everyone in the organization. Partition the net. Act if the network perimeter did not exist. Use security key for multi-factor A. Incorporate threats intelligence. Avoid motivating end users to circumvent security measure. How to implement zero trust security. For instance, Cloudflare One is SaaS platform that combines networking service with a built-in zero trust approach to users and device. With Cloudflare One's customer automatically implements zero trust protection around all their assets and data. Zero trust. Identity. Mhm. This is the eternal debate between security and freedom, bro. Mhm. Mhm. Mm. What is the language here? What the French is this? Exactly. Hmm. Okay. Oh crap. Hey, get in security frameworks. Okay. Hmm. Security policies. So you got SOC, you got zero trust. Hmm. So Cloudflare. So Cloudflare. Yeah, Cloudflare and IBM. Okay. 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 SOC 2. This is for auditing. This is for auditing. Hmm. Security policies, SOC, and zero trust. Data privacy, CCPA, CPRA, and GDPR, and Atlassian, and all of this. And I get it. What they're implementing is that CTNA, Zero Trust Network Access. On the Castle-and-Moat concept. Network perimeter. Mm-hmm. Least privilege access, microsegmentation, multi-factor authentication, and device monitoring. Every device that connects to a network is carefully tracked. Moving from castle mode to a zero trust. Mm-hmm. This is interesting because this kind of company actually are implementing is this. Castle-and-Moat model with a variation of this. But okay, all right, that was quite interesting because now, okay, I don't right now. I don't think you're able to see what I'm doing. Is this one? Okay. So why is this? You may wonder, right? Glad you do. If you don't, I'm gonna tell you. Mm-hmm. Okay. Cloud Security Alliance, GDPR, IPAA, SOC 2. All right. There are also quality management as well. For example, here in this you have this quality management. Quality management. So for example, like the ISO 9000 and ISO 4001. Okay. The first focus on that. The first focus on quality. Exactly. Quality control. Quality controls, and the other is environmental. Environmental management system. Okay. Okay, environmental management system. Environmental management system. Okay. So this is one of the things that we're slowly but progressively going to do, right? And again, we're going to provide all of this kind of things, bro. Yep. Yeah. Okay, so why this is important, right? Because especially if you're an admin, in a lot of companies actually out there. So here's the principle of least privilege. Companies with decent size will implement this kind of policies as a way to protect their assets, right? Their assets. So you get exactly. So companies with decent size will implement this kind of policies as a way to protect their assets. Okay. SOC 2 or N zero trust policy, bro. Zero trust security. That's very interesting. Very interesting. Very interesting. Very interesting. A word of security. Mhm. Because traditional IT network is based on Castle-and-Moat concept, which is prevent access. Okay. Traditional IT security. Interesting. Interesting. Come on, man. Why not? Okay. Okay, so traditional IT network security. Like traditional IT network security is based on Castle-Moat concept. It's the Castle-and-Moat concept, which is prevent access. Okay, to Wikipedia. How is access control managed in how access control managed in a Castle-and-Moat model? There are a few drawbacks of such approach. Vulnerability to attack. A VPN attack, a single point of failure for the application, and that it protected only takes one compromised account for a device or attacker to cross the proverbial moat and gain access to the VPN protected data. Slower performance. For remote employees, a VPN routes all traffic through the VPN server, which could be far away from the employee, slowing network traffic down further. Scalability. If VPN uses exceed the VPN server's capacity to handle traffic, the server has to be upgraded. A labor intense process. VPNs require a lot of time and resource to maintain. A team must be installed the right VPN client on every remote employee computer. Ensure employees are keeping that safe software is up to date and upgrade or replace VPN hardware regularly. User must provide more than one factor to verify identity. For instance, a password plus possession of a token. Device monitoring. Every device that connects to a network is carefully tracked. These principles are broken down further in that. So, because of that, right? The organization that use this model dedicate a lot of resources to defend their network perimeter. They deploy firewalls, intrusion detection system, intrusion prevention system, and other security products that block most external attack, but are not as effective as stopping internal attack, inside threat, and data breach. That's what happens. So, okay. Because this model is focused on protect themselves from external threats. Okay. With firewalls, with firewall. Yeah, with firewall. Yeah, with firewalls, intrusion detection system, intrusion detecting systems. Intrusion detecting systems. What the French stuff is this? Intrusion detecting systems. Intrusion prevention systems, intrusion prevention system, intrusion detection system, intrusion prevention system. Okay. Yeah, because this model focuses on protecting themselves by putting guardrails, by putting okay, protecting themselves just like in a castle. Which protects us just like in a castle from external threats, but poorly from internal threats, which is insider threats and data breaches. Castle-and-Moat is not necessarily a deliberately chosen strategy. The term came into use to contrast traditional network architecture with zero trust architecture. This is an architecture. You know, a common problem to a typical solution to a common problem. And what are the problems that with Castle-and-Moat approach? If they cross the moat, they can also access any data and any system within. They can breach the network by stealing user credentials, exploiting security vulnerability, introducing malware infection, or carry out a social engineering attack, among other methods. So the problem with this approach, which is the Castle-and-Moat strategy, network security, Castle-and-Moat network security model. Okay, so the problem with this approach, in fact, let me show you this. Okay, holy moly, bro. Okay. Because the admin provide right contributors the access to certain areas that are paramount to security. Admins here follow the principle of least privilege, a word of security, please. So company with decent size would implement this kind of policy as a way to protect their assets, SOX and zero trust. So Castle-and-Moat network security. This traditionally is based on a Castle-and-Moat, on the Castle-and-Moat concept, which is prevent access, which is great for protection from external threat by putting is firewalls, intrusion detection systems, intrusion preventing systems, and so on, but not for internal threats. The problem with this approach, the problem with this approach is that it assumes that each one of those inside of the castle are guards, and not only guards but also people's. They're all guards and intelligence, pretty much like SWAT team. It assumes that everyone inside of that is a SWAT team, which is not. So if they cross the moat, they can breach the network by stealing user credentials. If they cross the moat, they can steal credentials. They can steal, exactly. They can steal credentials, exploit vulnerability, exploit system vulnerabilities, system vulnerabilities. Okay, exploit system vulnerabilities, infecting, introducing malwares, exploit system vulnerability, steals credentials, introducing malwares, and carry out, exactly, or carrying out, okay, or carrying out a social, right, or carrying out a social engineering attacks. Exactly. This is the things that this is the problem if they cross the moat. The problem with this approach is if they cross the moat, they can not only steal credentials but exploit system vulnerabilities, introducing malwares, or carrying out social exactly, or carrying out social engineering attacks. That's why this zero trust policy, and I really love of this, is that if you're in a company where most of the time you don't know the people behind that, you don't have any relationship more than business, zero trust, bro. Zero trust, bro. Zero trust, bro. Mm-hmm. 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 Exactly. So, zero trust security model, which is something that is implemented by okay, and I get it because this kind of policies, security policies, okay, this kind of security policies is important to have. Focus on protecting themselves, just like in a castle, from external threats, but poorly from internal threats. So then you have now the zero trust security model, as their name suggests, trust no one. Trust no one externally or internally. But this is quite counterintuitive, because at the end of the day, business are based on trust. And if you don't trust that I'm going to provide you the value that you need to solve your own problems, it's like, this has an end. This has an end, bro. Mm-hmm. So, yeah. Device access control, microsegmentation, preventing lateral movement, multi-factor here. So this is one of the things here. Okay. All right. As the name suggests, trust no one internally or externally. Mm-hmm. So it say how and when users are allowed to access system data. It indicates how and when or where. I'm assuming it must be part. How and when users are allowed to access system data. Users are allowed to access system data. So the main principles here, the principles, it doesn't matter if I don't recall each one of them, but at least to have a notion of what's going on here. And that is continuous monitoring, and validation principles. Continuous monitoring and validation. Yeah. Conti is continuous, right? Continuous. Oh my god. Continuous. Jesus. Continuous. Okay, continuous. Jesus. Continuous monitor. Okay. Continuous. Alright. Continuous monitoring and validation. Jesus. List privilege. Okay, list privilege. Device access control. To control on user's device. Device monitoring. Microsegmentation. Multi-factor authentication. Okay, preventing lateral movement. Microsegmentation. And multi-factor authentication, which is MFS. Alright. Okay. This is interesting because this course or today's video was not about this. But I think this is something important as a way to, especially if you're going to be a UI specialist or a UI tech lead here, you need to actually provide this. You need to be aware of this. That's why encryption so far has been a proven the right approach. Because instead of actually now preventing this castle-and-moat, it's like, hey, please don't cross here. And if we're gonna make sure that no one passed through, which is great, but once someone crossed the moat, what happened? It's like, it's terrible. because now he can carry out social engineering attacks, or exploit security exploit system vulnerabilities, injecting his malwares, or stealing credentials. So one of these particular model, the zero trust security model, says we're not gonna trust no one internally here, and we're going to indicate how and when users can access to this. And the way they do that is by, well, principle of least privilege. You're gonna have only small amount of right here. Continuous monitoring and validation. Device monitoring is like, hey, who are you? Are you getting access to this? And who are you? Device monitoring, microsegmentation. So it says that networks are broken down into much smaller security zones, and to prevent lateral movement. So once an attacker get access to, try to move through one network to another, or it's like getting to one house to another. Once he's inside, when he was detected that is inside, make it much more hard to get there. Interesting. And the other is the multi-factor authentication. It's also the core value of zero trust security. Means that require more than one piece of evidence to authenticate a user. Exactly. More than one piece. The problem with this is like, this is now an excuse for companies to actually get the data as much as possible to check their individuals. Oh my God. Knowledge possession, biometric data, and locations. How does two-factor authentication work? Are the drawbacks of two-factor authentications? While 2FA is helping make the internet more secure, there are a few drawbacks that should be considered. For 2FS may discourage less technical savvy users, from whom downloading and navigating smartphone verification apps can be challenged. Requiring 2FS for a service can also create some economic barriers to entry. Not all users have the modern smartphone required for many 2FS. Additionally, mobile data is expensive in some part of the world. 2FS also impose business costs for those managing the service. 2FS is much more difficult to implement than password-only authentication, and business providing 2FS will either have to incur step costs and pay a third-party service to provide the authentication ongoing. Why use two-factor authentication? What is authentication? This is one of them. I get it. Okay, the most common thing is the two-factor authentication. But then we have the multi-factor authentication. What are the authentication factors? Knowledge, something that the user knows; possession, something that the user has; inherent quality, something that the user is. Okay. Which form of MF are the most effective? Attacker sends employee SMS phishing message pointing to fake logins for the organization's single sign-on service. If a user entered their username and password into their fake page, the following step took place. Are there any other authentication factors? Location and time. How can users implement MFS for their account? Using an SSS solution is a recommended step for implementing MFS. SSLs provide a single place for implementing MFS across all apps, where not individual apps will support MFS. Okay. MFS is an important part of identity and access management, and it is often implemented with single sign-on solutions. It's because it's working with tokens. Okay, that's interesting. So that'll be all for this video. Take care. Bye bye.